Let's not use a Stabiloc. 'Tis a stupid instrument. Can't even switch the bloody thing off. Well, I'm sure many of you are going to be familiar with the Book of Genesis. Well, one part that was actually left out was that on the seventh day, when God rested, he basically walked around the house in his bedroom slippers for the morning, then went down the pub for a lock-in. But what it also didn't say, that on the eighth day, he created the Marconi 2955 test set. It's a wonderful piece of equipment. Even an idiot like me can operate it, more or less. Well, I'm sure some of you will be familiar with these communication test sets and some of you won't. But basically what we've got here, it's a range of instruments which are all built into a piece of test equipment. So it consists of things like a dummy load, a very sensitive calibrated radio receiver. It also contains a very sensitive transmitter that's got very fine attenuation. It's got power meters built in, so we can measure RF power, we can measure AF power, and we can also measure things like distortion. So it's a whole host of equipment that you might have sat on your test bench, and it's all been neatly packaged together into a convenient unit. Now, of course, you don't need a communications test set to work on radios. You don't need one at all. I didn't have one for years and years and years. But what it will do is, if you get one, it frees up an awful lot of bench space. Now, one of the downsides of these is that unfortunately they're going for quite a lot of money now, these test sets. I would say that they're typically going for anywhere between £500 and £1,000, and a really nice one is probably going to cost you nearer to £1,000. But they do have some problems that they can be a little bit hard to repair. They have some op amps inside them which do suffer and fail quite regularly. This one has been in bits more than once, and also they have I think it's an oven controlled oscillator in here. Well, they have a habit of degrading. They have some like foam packing material around them that goes a bit manky and falls apart. So if you are buying one of these, be a little bit careful. This one isn't perfect. I think it's got a few problems with some of the attenuators on it. Probably nothing more than the dirty, but yeah, this is what you find with old equipment. So I probably don't recommend you buy one unless you drop on one at a good price. I've got various boxes and gubbins and things plugged in. Well, what this box is here, it performs a couple of functions. It takes an audio, it replaces a microphone on the CB radio here. So what I can actually do is I can output an AF tone, which is typically something like a 1 kilohertz tone. So rather than whistling into the microphone, this will very accurately deliver a calibrated audio tone, which the radio, the CB, will then transmit, and that will come in through this RF connector here, and it will show us what the power is coming in at. But it'll also do things like it'll demodulate the audio, it'll strip it away, and it'll tell us the quality of the audio, if there's any distortion and stuff like that. But what this box does is, depending on how your radio is wired up, and this is something I've had problems with in the past, you want to, for some of the tests, you want to feed the speaker connection back into the Marconi test set, and you've got to be very careful that these connectors on here are grounded. Well, some of the outputs on amplifiers on radio equipment, they're floating, and what you can quite easily do is you can short out the output of the amplifier. You can tie one side of it down to ground, which it's never done any damage, but basically it can give you a bad day. You get all kinds of odd readings, and it's probably not good for it. So what we've actually got in here, I've just got two 1-to-1 audio transformers. So they're isolation transformers. So not only is the microphone, well, I guess you call it the microphone output, that goes through an audio isolating transformer, and also the speaker input, which I would connect to here, that goes through an audio isolation transformer before I take it back into the test set. So a bit of a trap for young players there. When you are testing up when you're connecting any type of test equipment, even normal signal generators or normal voltmeters, when you're starting connecting to microphones or to speaker outputs, you've got to be really careful that you don't short out inputs and outputs. It's really easy to do. And the particular amplifier that it uses in here, I've got no idea what it is. I haven't got a circuit diagram for it, so hence we're using this audio isolator. The other thing that this box has got on it is I've got a couple of push buttons. Well, I've got a push button there and I've got a flicky switch. So what this allows me to do, it allows me to key up the transmitter remotely. So this connector here, this wire comes out of here. Let me bring you around so you can see. So you hopefully can see I've got a microphone connection here. So that comes out of here and it goes into the microphone connection on the side of the radio. And if I press this button, I can actually key up the transmitter. So can you hear that tone? That tone isn't coming out of the radio. It's actually coming out of the 2955. So what's happening there is I'm taking audio. I'm getting a 1 kilohertz audio output because it says here AF generator 1 kilovolt at 1 millivolt. So I'm feeding a 1 millivolt connection. It's coming out of the test set. It's going down this lead through the isolation transformer. It's going down this wire here. It's going into the microphone connector. The radio's taking the audio input, which is just the same as having a microphone connected, and it's modulating that, and it's transmitting it. So the transmitted power is coming out of this coax here, and it's going back into the test set, and then the test set is demodulating that radio signal, and that's the audio tone that we're hearing. So I can press this button to key it, or I can flick the switch, and now it's going to constantly transmit. If you do put a latching switch on it like that, you've got to be a little bit careful, because if you walk away you could end up frying your finals, because most transmitters aren't 100% rated. You shouldn't leave them transmitting like this for very long. So we'll switch that off. Well, at this stage of the repair I'm still very much in the assessment stage. The radio isn't working. Yes, it's transmitting and it's probably receiving, but I wouldn't class it as a working radio. I haven't decided if I'm going to keep this yet, so at the moment I'm just evaluating it. Unfortunately, it's no use to me as a radio in the UK. I can't actually use it because it would be illegal, because I said earlier it's an AM radio. But if I was to keep it, what we'd probably look at doing next is we'd look at replacing all of the various capacitors inside it, because let's face it, after 40 plus years, I think this radio is around, I don't know, late 70s, maybe early 70s, I'm not dead sure, but after 40 years you can bet your bottom dollar that every one of these electrolytics needs replacing. But I'm not sure whether I want to invest the time in it for a radio that I can't use. It's a learning vehicle. I'm only using this radio to learn from. I said earlier, I'm not an expert on radios. My thing's test gear. I buy test gear because I'm interested in test gear. I'm not actually that interested in repairing stuff. So this radio's at the assessment stage. So what I'm planning on doing is I want to do some before tests and maybe some after tests when we've tried to improve things. I haven't got any circuit diagrams for this, and the next thing I would want to do for it, once I've replaced the capacitors, I want to do a full RF alignment on it to see if we can improve the performance of it. But before we do those performance tests, we want to know what it's doing now, because you want to know if you've improved it, don't you? You want to know if it's better or worse. I can't actually put this radio on the air and talk to people, so we're going to rely on the test equipment to tell us how well the radio's working. Alright, enough waffle, sorry. Now the first thing I'm going to do is I'm going to do a transmitter test. So the way that we actually do that, first of all, it's already in transmitter mode, but you would normally need to press TX, so now it goes into transmitter mode. So the test set is now waiting for an RF input. So if I actually key up the transmitter, what it's going to do is it's going to send out this AF signal into the microphone, and the microphone level at the moment, I've got it set quite low. It's set to 1 millivolt, hopefully you can see that, 1 millivolt. And the test tone we're going to use is 1 kilohertz. 1 kilohertz is a very typical frequency that people use for testing radios. A lot of the tests are specified for a 1 kilohertz test tone. I'm going to key up the transmitter, and what we should see on here, we should see the power that the radio is transmitting. So we're on channel 20 at the moment, so let's just make the transmitter transmit. I'm going to click the PTT switch, and again, can you hear that? And it's telling us a few things here. It's saying that the power output from the transceiver, it's saying it's just under 3 watts. Well, it's 2.5 watts at the moment. And it's also telling us the AM modulation, which at 1 millivolt is actually pretty low. 1 millivolt, and that's saying that we've got, well, about 18% modulation. It's got a bar graph here, and it also displays, I think, the average there, which is 18. I think we can also make it display distortion level as well. Is that distortion? Is that it? Okay, distortion level. And it's saying that at the moment we've got 2.1% distortion, which I actually don't think is too awful. I don't know what to expect though, so again, some of you guys in America who repair radios and have these test sets or similar, perhaps you can comment on the numbers I'm getting. So we're set to channel 20 at the moment, and that does coincide there to the TX frequency, which says 20.499. Now I have actually tweaked that slightly. It was low, which you expect it to be low because you get crystals aging, and when they age they drop in frequency. So I have actually tweaked it up because it was just a little bit low before, and at the moment it's just flicking between 499 and I think 498. So maybe we could tweak that up a little bit more, but I think I'll leave it for now because we're in the ballpark. Right, okay, so we're receiving, the power we're getting back from the radio is 2.53 watts. What I think we should do is we should turn up the microphone level, because I want to simulate somebody shouting into the microphone, because what I want to know is that the AM modulation doesn't go to 100%. Again, I'm not sure exactly what figure we should be looking for, but I'm guessing we want to see no more than about 80%. So let's do that. So I'm just going to select the AF generator level, which is AF gen, then we press the level button, and now I can use this variable control. So we're at 2 millivolts now, and there's a big increase in noise coming out of the test set there. So the signal we're receiving is now a lot stronger, and you can see that we're now doing 31% modulation, and the distortion's gone down a bit because, well, I'm guessing that is because we're getting above the noise floor. Let me turn that down because you might not be able to hear me. Let's go a little bit louder. 3 millivolts, 4 millivolts, 5 millivolts, 6 millivolts, keep going up. Okay, well I'm increasing the microphone volume now, but the modulation is only increasing very slightly, and that's because the automatic level control is switched in, so it's not allowing me to over-modulate the signal. I'm not really worried about going much above 30 millivolts because unless I'm using a power mic or something like that, we're not actually going to be able to actually put that much drive into the radio. So I actually think that's probably okay. But let's have a look at that on another piece of test equipment. Let's have a look at what that transmitted waveform looks like on both the oscilloscope and the spectrum analyzer, because I think that'll be interesting. So to do that, I'm going to remove the RF input from the communication test set. I'm going to plug it into this tenor-line attenuator. I think this is the 30 dBm one, sorry, the 30 dB attenuator that we saw earlier. It's going through there, it's having the level reduced by 30 dB. It's going into my spectrum analyzer here, which is terminated in 50 ohms, and it's also going into the scope here, which isn't terminated in 50 ohms, it's just the normal scope. What is it, 1 mega? Is it 1 mega ohm? Something like that. 1 mega ohm input. It doesn't really matter because at this frequency and this length of cables, the input impedance is going to be dominated by the 50 ohm connector here, so that's going to be good enough. Come on, wake up, scope. In fact, we'll just turn that off there. And let's turn on the modulation again. It was. So you can see our AM modulation there. If we zoom right in, we'll be able to see the underlying RF waveform there. So there's our 27 megahertz signal. We'll zoom back in. And there's our audio modulation riding on top of the carrier. Now, at the moment, I had the microphone input set to 1%. So let's just unfreeze that. And I'm just going to reach around the camera. Sorry if I knock it. I'm going to increase the microphone volume, which is the equivalent of just shouting into the microphone. So let me just do that. And can you see that the modulation is increasing there? and that's taking it up. I'm putting a really high input level there. I'm actually putting 50 millivolts into the test set. Let me just freeze that. Sorry, I'm putting 50 millivolts into the transmitter at the moment. Let me freeze that, and I'm just going to turn the transmitter off so nothing warms up. So again, here's our 1 kilohertz, but can you see that the depth of the modulation, it's cut into the carrier much deeper there? But I'm not unhappy with that, because we're not actually splitting these things up. What you'll tend to find, and again, I was watching Mike's radio repair the other day, and he was talking about transmitters that had been modified to have too much modulation. And what you'll find is, rather than being nice sine waves here, if the radio has got too much modulation, you will get what he calls boxcars. So you can imagine a line of trains where you have one carriage, then a gap, then another carriage. That's what you will get. You will get boxcars. But we haven't got separate boxcars. We've got a nice sine wave here, and the actual the modulation isn't cutting off. It isn't going below zero, because you can find you get these little separate boxcars. So I'm not exactly sure what the levels should be for an AM transmitter. I'm going to guess and say that's fine. I'm sure maybe we could improve it a little bit when we do an alignment on the radio, but I'm going to put my taters on the bench here and say I think that's okay. Leave it in your comments. Well, I have to say my workshop is lovely and warm and toasty, because whenever I switch on this spectrum analyzer, this Marconi 2380, it's got some big fans in the back, but everything does get pretty warm, and even this Keysight oscilloscope actually gives out a lot of heat. So yeah, feeling very nice and toasty in here at the moment, which is great because it's a horrible wet winter's day. Okay, let's see if we can see some some spectrums on here. So we've got to choose the frequency we want to look at. So reference frequency, I'm going to set it to 27 megahertz. Going to increase the span. Oh, sorry, reduce the span correctly. Let's have a 1 megahertz span. Let's key up our transmitter again, and there we can see our waveform. Where's it gone? Reference level a bit high. Let's turn that down again. Okay, that doesn't look too bad. Oh, it's bobbing up and down a bit. I don't think that's a normal. Let's put a little bit of averaging on it. Video average. Okay, let's clean that up a little bit, and let's just try and centre that in the centre of the screen. So we're on channel 20 at the moment. Let's just get a frequency reading off the spectrum analyzer. So find peak, and it's saying that we've got 27.501 megahertz. Can you see that? Let me bring you in. What I'm going to do is I'm just going to reduce the span, so we've got 10 kilohertz per division, because that is then going to show us the channel spacing, because we use a 10 kilohertz channel spacing on these radios. So let's just let that settle down. In fact, let me take that video averaging off because it's slowing it up a bit, and I'll just recenter that. And what I'm going to do is I'm just going to freeze that there. So we'll do save. Oops, what did I press there? Don't know. So it's save that. I'm just going to stop it transmitting, and I'm going to go up one channel. I'm just going to go to channel 21, and I'm going to turn on this this second trace view, and we will turn the transmitter on again. And you can see it's now transmitting there, so we'll save that one as well. Turn the transmitter off again. So we can see that we've got two peaks there, and we can actually see that because I've got 10 kilohertz per division set up, we can see that we have got 10 kilohertz difference between these two incoming RF waves. What do we call them? Waves? They're not waves, are they? Spectra? I don't know. But they're 10 kilohertz apart because the peaks of them are lining up exactly with the 10 kilohertz marks. What would be of interest to me here is, at what point do the two waveforms start to, I don't know, mesh over each other? because that's really going to start to tell us stuff about whether one channel is going to interfere with another, if we're going to be transmitting on adjacent channels. And just looking at that, and I'm looking at the carrier, it looks like we're at least, looks as though we're at least 50, maybe 60 dBs down on the carrier. So I would have thought that one channel isn't interfering with the other. That's just a very quick and dirty test. I don't know if that's right. Again, leave it in your comments, tell me what you think. So we've got some baseline figures there for the transmitter. Let's just have a quick look at how well this radio is receiving. So we'll disconnect our signal that was going into the spectrum analyzer and the oscilloscope, and we'll plug it back into the test set. So we're now going to use a communications analyzer to test the receiver performance of this radio. So what we're going to do is we're going to output a very low level RF signal, and it's a calibrated known RF signal, and we can turn the RF signal up and down, and we can start to see where this starts to pick it up, to see how sensitive it is. So let's have a go at that. Unfortunately, I've got to make one little change. Although this lead here that I've got connected will key up this transmitter, it has a fourth pin which is used to enable the audio amplifier, and unfortunately I don't have that pin connected in this box at the moment, because the other radios I've tested in the past don't seem to require that amplifier enabled path. So we're just going to plug the original microphone back in, so we'll do that. And let's turn the sound up and the squelch off. I'm going to turn RF gain fully up. I'm going to set the tuning to the centre position. Squelch off. So can you hear that tone now? Well, hopefully you can hear that tone. That's being received by the radio here. And what we're actually transmitting to this radio is a very low level signal. Let me bring you in on the screen. So the RF output from the test set, it's actually 107 dBm. And another way of saying minus 107 dBm, that's actually 1 microvolt. So this radio is actually sensitive. I would actually say it's picking it up quite loudly now. It's picking up that 1 microvolt signal. So that's actually, I think that's pretty amazing for what I would call a cheap and nasty CB. I've seen communication receivers that haven't done that. So that's pretty impressive. Let's just increase the signal a little bit more because it's a bit scratchy. So let's just increase that signal to 2.5 microvolts, which is minus 100 dBm. So that tone now is actually pretty loud. I can hear that very, very clearly. So in terms of receiver alignment, receiver sensitivity, I'm quite impressed with that. When we actually start twiggling, when we do an alignment on this radio, I actually think we'll be able to do a lot better than that as well. Let's just see if we can fully quiet by increasing that output from the signal generator on the communication test set. Okay, so that's fully quietening now, I would say at minus 63 dBm, so there's no background hiss. We're a long way above the noise floor. I can't really any hiss anymore, I can only hear a tone. And as I said earlier, I think we could improve on that by carrying out an alignment on this radio. But I'm not planning on carrying out an alignment at the moment, because the main reason I'm not planning on carrying out an alignment is a simple one. I don't know how to do it. I haven't got the practice or the skill to just dive in here and start twiddling things. What I have done is I spoke to Mike of Mike's Radio Repair, and he put me on to a Sam's manual, which is, I think it's an American printing company, long since deceased, but they used to have the equivalent of our, what they used to call them, trader sheets in the UK. They used to print all circuit diagrams and maintenance information for all kinds of radio equipment and videos and domestic stuff like that. And he said that it was Sam's number, catalogue number 214 for this. So I've gone on eBay and I bought the magazine. I bought issue 214, which details the alignment procedure for this radio. So what I'm going to do now, I'm going to put this onto one side, and we'll have to wait until that magazine comes in a few weeks' time, because it's been shipped from America. And when it does come in, we'll have a go at having a go at radio alignment. But until then, it'll be useful to see some comments, especially from you American boys who I'm sure play with CBs all the time. Give me some tips and tricks, and tell me, is what I've done so far, is it reasonable, is it looking okay, or am I completely barking up the wrong tree? So if you could do that, that would be great. Thanks very much.